All right, so with 13.4, we are keeping on the same path that we were on in 13.3, where we're trying to find values for sine and cosine for angles that don't appear on the unit circle. Okay, so we're going to use these things called double angle identities and half angle identities. So starting with the double angle identities. So we have sine of 2 theta, so if you want to double an angle, it's equal to 2 sine times cosine. Okay, and then we have 3 different ones for cosine. It probably makes the most sense for you to just kind of like hone in on one, but I'm going to give you all 3 of them anyway. So our 3, we've got cosine of 2 theta. One of them is equal to cosine squared minus sine squared. This is the one you'll see the most frequently, so we'll probably end up using that one for the most part, but like I said, there are 2 more. So we could also use 2 cosine squared minus 1. And that just comes from our Pythagorean identity, because remember, sine squared can be written as 1 minus cosine squared. So it gets rearranged like this. Same thing with this one. This one's really similar. This one is 1 minus 2 times sine squared. And that's because we can rewrite cosine squared as 1 minus sine squared using the Pythagorean identity. So they're all really similar. And then let me sneak in. Probably should have left myself more room, but here's tangent. Tangent, we've got 2 times tangent, and then over 1 minus tangent squared. You've probably noticed from the last couple sections that we aren't using these tangent ones as frequently as we're using sine and cosine, but we do have double angle formulas for them, so I'm going to give them to you. So find the exact value of cosine of 2 theta if, and then we give you sine is 5/4, and then we know that the angle is somewhere between 0 and 90 degrees. All right, so that'll help us figure out whether it's positive or negative. So finding the exact value of this, we are going to write down what cosine squared is equal to. Now, it is important here that we have 3 different values, because depending on what you're given, you'll be plugging it into a certain one of these formulas. So all we're given is sine, which means we're going to plug it into this version of the formula. All right, so I'm just going to write down the formula we're going to be using, then we'll plug everything in. Okay, so we want to find this, and what we're going to do is plug in this sine value right here. So that is 3/4. Sorry, I kind of ran our line right into it. So remember this notation, sine squared, like just a quick little note, when you see notation like this, what it really means is you're taking whatever the sine value is and then squaring it. Okay, so that's anytime you see that notation. Same thing with cosine, tangent, whatever. So it means we're taking that value and squaring it. So let's simplify it piece by piece. First thing to do is square that 3/4. So square the 3, square the 4, and then we can keep simplifying. So 1 minus 2 times 9 is 18/16. And then we want to get a common denominator. So 1 minus, first of all, this reduces down to 9/8. And then I have 1, I can write it as 8/8. Minus 9/8, and so that leaves me with -1/8. All right, so this is a negative value. Important thing to note is that theta itself is somewhere between 0 and 90, but I'm doubling that angle, so it could end up anywhere between 0 and 180. So that is why this value ended up being negative. Perfectly normal. It just means my angle is big enough that doubling it pushed it into the second quadrant. All right, so that's one example. Next example, we're going to find tangent of 2 theta, sine of 2 theta. So this is the value that's given to us right here. And then we know that the angle is somewhere between 270 and 360. So the angle is somewhere in the 4th quadrant. So now we're going to find tangent of 2 theta. So again, I just want to keep that formula on the screen so we know what we're using. Okay, so first thing to note is that we need to know what tangent is. We don't know what tangent is, and we're not going to be able to plug it into the formula until we figure out what tangent is based on this value of cosine. So remember, we did this in a previous section. We had to use this to figure out exactly what our value of cosine was. So we can do that by setting up a little triangle. Okay, so I'm going to set up a triangle like this. I know that my cosine of this angle theta is 4/5. Cosine is the adjacent over the hypotenuse, And this is a 3, 4, 5 triangle, so I know this is going to be 3. Important though, it's going to be -3 because I'm in the 4th quadrant, so that means my y values will be negative and my x values will be positive. So this is my triangle here, and I need to make myself a little note that tangent of this angle, opposite over adjacent, will be -3/4. So I find that value, and now that I know it, I can plug that value for tangent into this formula right here. So 2 times, now tangent theta is -3/4 over 1 minus, remember tangent squared means you're taking that entire quantity and squaring it. Okay, so let's simplify that up. 2 times -3/4, this 2 is going to reduce this down to 2, so I have -3/2 in the numerator over 1 minus, then when I square this, it doesn't matter that it's negative, it's going to come out positive either way. So square the 3 and square the 4. Lots to simplify up here. I have -3/2 in the numerator over, and then in the denominator, I can write this as 16/16 to get a common denominator. So 16/16 minus 9/16, that leaves me with 7/16. And last little thing, remember dividing fractions means you can multiply by the reciprocal. So take this, and instead of dividing by 7/16, you can multiply by 16/7. So this will reduce down to 8, and we're left with -24/7 would be the value for your final answer. All right, sine of 2 theta. Again, I'm going to copy that formula down. It is 2 times sine of theta times the cosine of theta. So this represents the exact same value here, so I can go off of this triangle again for these values. So 2 times sine of theta, if this is our angle right here, sine would be opposite over hypotenuse, so -3/5, and then cosine was given to us as 4/5. So I'm going to simplify all this up. I can think of this like 2/1 just to make things easier. 2 times -3 is -6, times 4 is -24, over 1 times 5 is 25. That one is way simpler than the tangent one. All right, so that's our double angle stuff. I've got our half angle identities here as well, and then we can finish off with some more examples. So half angle identities, got sine of theta divided by 2 is either plus or minus, so these will depend very much what quadrant you're in, whether you choose the positive or negative version. Okay, so that's our sine formula. Half angle formula for cosine also starts with a plus or minus. And then the only difference here is we have 1 plus cosine. And then finally we have our tangent formula. Also plus or minus because we have a big square root. And this is 1 minus cosine divided by 1 plus cosine. Remember, tangent was defined as sine over cosine. So when you divide these two together, that's how you end up getting this quantity right here. So they are very similar to each other. So that's our half angle identities. We're going to use those identities to solve some of these things right here. So find the exact value of cosine of theta over 2. So we're going to start just by copying that formula down, just so it's right in front of us and we know everything that we're plugging in. Okay, so our formula has a cosine in it. We got to make sure that if we have a cosine and we're given sine, that we can figure out what cosine would be. So we're going to start by setting up our little triangle here. Okay, so theta's in the second quadrant. That's going to tell us whether all the pieces would be positive or negative. So sine of this angle is opposite over hypotenuse. This is again a 3, 4, 5 triangle, but because I'm in the second quadrant, my x value is going to be negative. Okay, so set up a little triangle. This is a super important bit of information to know. So because of this angle right here, cosine is adjacent over hypotenuse. So this would be the value of cosine that I'm plugging into this formula. So I have 1 plus cosine would be -4/5, and then over 2. So I get plus or minus square root of 1 minus 4/5 would be 1/5, and then divide that by 2. So instead of dividing by 2, I can multiply by 1/2, and I end up with plus or minus the square root of 1/10. Okay, so here's what I'm trying to figure out here. We want to know whether I'm using the positive or negative version of that 1/10. And I figure that out by looking at the quadrant that I'm supposed to be in. Okay, so if I'm in the second quadrant, so second quadrant means that theta is somewhere in between 90 and 180, which means that theta over 2, I would divide all this by 2. If I cut the angle in half, then it's going to be somewhere between 45 and 90. And if it's somewhere between 45 and 90, then it's in the first quadrant, which means that this should be the positive value. So take the square roots, make them positive. Square root of 1 is just 1, so you're able to break that out of the square root. Okay, so that would be your final answer for that. And again, a little play with the angles here to figure out whether it would be positive or negative. Okay, we're going to do something a little bit different with these. Find the exact value of the sine of 165. So 165 is half of 330. So we can write it like this. Half of 330. So we can use that in our sine formula. Okay, so it becomes this. Plus or minus square root of 1 minus cosine of the angle in question, which is 330 over 2. Okay, so this is just coming off of this formula right here. So I'm using 330 as theta because that's how I get 165. So plus or minus square root of 1 minus, and now this, remember we've got tons of these values on the unit circle, cosine of 330 degrees. 330 degrees is right here. Cosine of that angle would be square root of 3 over 2. Okay, so I take the square root of 3 over 2. And then divide that all by 2. So let's clean this up. This is going to be a very strange little value with a square root inside of a square root. So let's start with the plus or minus. Sine of 165 degrees, that's in the second quadrant, so that's going to be positive. So we can start by just taking the positive value. This 1, let's write it as 2 minus 2 over root 3 over 2, and then I still have a denominator of 2. So I can clean up this numerator at least, like I can combine 2 minus root 3, put all of that over 2. So that's like this numerator here, and then divide the whole thing by 2. Okay, so we're getting there. I know this is getting ugly. 2 minus root 3. Here's what I'm doing. I'm dividing by 2, and then I'm dividing by 2 again, which means I'm dividing by 4. So finally, big square root of 2 minus the square root of 3, and then the square root of 4 is just 2. So not a pretty answer, but that is what we would get for the exact value of the sine of 165. Okay, let's look at another one here. Exact value of the cosine of 7 pi over 8. Okay, so this one would also be used as a half angle formula. That is half of 7 pi over 4. Okay, so that's this angle right here is half of 7 pi over 4. So we can set up a cosine half angle formula. Okay, so the angle in question, the theta, would be 7 pi over 4. Okay, this is a value that could also come right off of the unit circle. So if you pull that off the unit circle, the cosine of 7 pi over 4 is square root of 2 over 2. And all that over 2. Okay, so just a lot of the same ugly algebra stuff that we're going to be working with here. So remember 1, we wrote it as 2 over 2. So I can add those together. 2 plus the square root of 2 over 2. That's this whole numerator, and then all that over 2. So just like the previous example, if I take this, divide by 2, then divide by 2 again, it's like dividing by 4. So finally, for my final answer, half of 7 pi over 4, this angle right here, 7 pi over 8, this is actually going to be in the second quadrant. 7 pi over 8 is just smaller than pi, and that's where you'd mark your angles. So something like, pi would be right here. So that's 7/8 pi, so it'd be somewhere like there on the unit circle. So it's in the second quadrant. Cosine is going to be negative. And I take square root of 2 plus the square root of 2. And then in the denominator, the square root of 4 is 2. So that would be your final answer. So a lot of ugly things that we're going to be working with here. All right. And then one last thing, just identifying that this value right here is in fact an identity. Okay, so we're going to clean that up a little bit. So sine of theta, we're just going to leave it We're actually also going to leave cosine squared of theta. This is the one that we're going to clean up here. All right, so cosine of 2 theta. So what I want to write is the formula that we had right here, cosine squared minus sine squared. So that's what I'm going to plug in. Okay, so we're starting with the more complicated side, which is this side right here, and I replaced this with one of my double angle formulas. So I'm just going to clean this up. So cosine minus cosine, these end up canceling each other out, and then I have sine theta minus a negative, changes that to just a normal sine squared, and this is sine to the first, this is sine squared, so it ends up being sine cubed of theta, and this is sine cubed of theta. So once you simplify it up and find that both sides are equal, that means that it's verified.